In example, we were given that the center of our ellipse is at the point 1, 2, the focus is at 1, 4, and it goes through the point 2, 2. So I'm going to start by just plotting the information that we were given about our ellipse. Going by both ones on the x and the y-axis, our center is here at the point 1, 2. The focus is at the point 1, 4. So we have a focus right here. That automatically tells us that our little c value is equal to 2. So we can find our second focus by moving 2 units below the center. So our second focus is going to be at the point 1, 0. There's our F2. We got that from moving 2 units down from the center. We can also tell that this ellipse runs with its major axis parallel to the y-axis. And so it must be that the a squared is under the y term, since this runs vertically instead of horizontally. We know that this ellipse goes through the point 2, 2. So I will put that there. We're going to start filling out some information here so we can find either little a or little b. Technically speaking, the fact that the ellipse goes through the point 2, 2 does give us the value of little b, because little b is the distance from the center to the right and the left of those two endpoints of the ellipse. But let's go through it where we use the point 2, 2 in case we have an example that does not give us the value of little b. So I'm going to start by plugging in what we know for the center. We know the center is at the point 1, 2, so our h is 1 and our k is 2. I'm going to plug in the point 2, 2. I'm plugging that in for x and for y. So we have 2 minus 1 squared divided by b squared plus 2 minus 2 squared divided by a squared is equal to 1. The entire second term goes to 0 because 2 minus 2 is equal to 0. So we're left with 2 minus 1, which is 1, squared, which is still 1, divided by b squared is equal to 1. And we are able to solve this equation to see that little b is equal to 1. So we just verified what we already knew since the ellipse goes through that point 2, 2. Now we want to find our little a squared. And so we're going to use the equation that b squared is equal to a squared minus c squared to solve for little a. So we have 1 is equal to a squared minus 4. I just plugged in b squared and c squared to see that little a squared is equal to 5. And so our little a is equal to the square root of 5, which is approximately 2.23. Well, approximately 2.24. So we move 2.24 units above the center to find one of our vertices. I'll put that about right there. And 2.2 units below to find another one. And then connecting these points, we see that our ellipse looks something like this. And then finally, I will find the coordinates for our vertices. I'm going to take my center, which is at the point 1, 2, and I'm going to add the square root of 5 units to the y coordinate to find what I'll call v1 at the top. That'll be 1, 2 plus root 5. We just moved a units up from the center. The second vertex will be a units below the center, and so that will be 1, 2 minus root 5 down there. And now that we know all this information, we can lastly write the equation for this ellipse in standard form. I'm just going to fill out a squared and b squared to this equation right here. So we have x minus 1 squared, and we will divide that by 1. We don't have to write that, but our b squared is 1. Because our b is 1, when we square 1, we still get 1. And then y minus 2 squared will be divided by 5, because our a squared is equal to 5, and all of that is equal to 1. And so that is the standard form for the equation of this ellipse.